Today we're going to be examining word problems involving decimals. We're going to be taking a look at all four operations, and we're going to examine which operation the word problem is asking us to solve. There's a couple of rules we want to make sure we clear up. We need to make sure that we're looking for those key words that signal what operation we're doing. Each operation has those signal words that are telling us what operation needs to be done. Now, sometimes it gets a little tricky on what operation we're doing. So we want to make sure that we examine each key word and really think about what is the problem asking me to do with these numbers. Some common addition signal words might be the word total, how many, or an all. Now remember, when you're looking for addition, you're thinking about the numbers and just putting them together. So usually for addition problems, we don't have a lot of things happening with the numbers except combining them. Sometimes you see the word and. Multiplication, however, is very similar to addition. We might see the words how many and total again, so be careful that you're actually looking at the word each. Usually when you see the word each, you're multiplying. Therefore, if you see a number being repeated, such as she has 5 apples in each basket, we know that the word number 5 is being repeated. Therefore, it's multiplication and not addition. Subtraction, however, is a little easier. We know that when you're left with something is what you have at the bottom. So left or away is usually when you're subtracting. Now, you also want to take a look at the words how many more or than. When you're asked the words how many more or than, you're comparing numbers, which means you're looking for the difference between them. That's when you're subtracting. Division is very similar to multiplication. You might see the word each as well, so don't just automatically assume that you're multiplying. Be careful with this. If you're given the total, you're most likely dividing. Division always already has the total, and you're looking for a piece within that group. Now, for all multiplication, addition, subtraction, and addition problems, we're going to be using cubes. All the word problems that we're going to be discussing have a lot of information. Cubes is a way to annotate the problem to make sure we're focusing on the most important and that we're picking the correct operation. The C in cube stands for circling the key numbers. We want to make sure we circle only the key numbers we're going to be using in the problem. U stands for underline the question. It is important to underline the question so you can focus on what is being asked and what you need to do. B is box in any action words or those signal words we were just talking about. Boxing in those keywords is really going to help you with what operation you need to do. E stands for eliminate. Get rid of those unnecessary information. Think about what the problem is really asking, and is it important to know that information or not? Sometimes when you eliminate the information you don't need, you can focus more on what's important. Finally, solve and check. It's extremely important to check your work. Always check the answer you got and see if it makes sense with what the problem was asking. So let's take a look at some problems and use cubes to solve and evaluate these problems. So let's identify the operation and then solve. Here's our word problem. Jenna is buying groceries for dinner. Ravioli costs $3.25. Salad costs $1.15, and bread costs 35 cents. Now, the question says, what is the total cost of her groceries? So we're going to use cubes to annotate this problem and figure out what operation we're going to do. Here is my cubes completed. I've circled my numbers, I've boxed in those key words, and I've underlined the question. Now, I need to solve to figure out what operation this is telling me. So I see the words and total. And if I reflect back to my keywords, I know the word and means to combine and total means all together. So I believe I'm going to be adding these three numbers because it doesn't tell me to do something over and over again. It's not asking me what's left over, and I'm not putting it into groups. So I must be adding. Once I add my problems, I get $4.85. When I check back my work, that sounds pretty much correct because everything kind of adds up to 4. Let's continue. My next problem. Jerry takes trail mix on hikes. A package of diced apricots weighs 25.5 ounces. Jerry divides the apricots equally among 6 bags of trail mix. How many ounces of apricots are in each bag? Let's go ahead and do our cube strategy and figure out what operation needs to be done. So I see here that my numbers, I have 2 numbers. I have keywords, and my question is asking how many ounces are in each bag. So my keywords indicate that I must be dividing. Well, this was a helpful tip because it said divide in the problem. I must be dividing. Now, I'm going to go ahead and eliminate this first sentence because knowing that he's going on a hike doesn't really add to my problem. It really doesn't matter what he's doing in this problem to help me figure out the answer. Therefore, I'm going to make my problem in its division. I'm going to divide 25.5 divided by 6, and I get 4.25. Now, to know which number goes first or second, first I have to think about what he's doing. He has packages of diced apricots, and he divides those same apricots into 6 bags. That means 25.5 was my total number, and he's going to break that apart into 6 bags. Understanding which number goes first and second in our division problem is extremely important to make sure our division is correct. The next problem, giant tortoise move very slowly. They can travel a distance of about 0.17 miles in 1 hour. If it travels at the same speed, how far could a giant tortoise move in 4 hours? So let's do our cube strategy and figure it out. Once I've done my cube strategy, I found out that my keywords here are kind of hard because I don't have too many. But I do see the word in 1 hour and same speed. Now this tells me that he does something in 1 hour and they want to find out how much time he does it in 4 hours. So that means 0.17 is being repeated 4 times. Therefore, I can figure out that this is probably multiplication because multiplication means to repeat. Now, I can cross out giant tortoise move very slowly because that doesn't really add to my problem and it doesn't really help me solve. So that's just extra information. So I go ahead and set up my problem. It's 4 times 0.07, which equals 0.68. Now, I can check my answer and know that this is correct because I learned back in multiplying, dividing fractions, or decimals, that if I count the number of spaces in my factors, I should have the same number in my answer. Therefore, I have 2 spaces and 2 spaces. Here's the last problem. Josh ran 32.4 seconds in the race. Jessica ran 36.7 seconds in that race. How much faster did Josh run than Jessica? Now, I'm going to use my cube strategy and I'm going to box in my circle my numbers, box in my keywords, and underline my question. Now, I notice that the keywords here are how much and the word than. Now, I remember that signal words of than mean to compare, which means I'm looking for the difference between Josh and Jessica. Now, because I know in subtraction my greater number needs to come first, I'm going to be taking away Jessica's from Josh. Another indicator of knowing that 36.7 must come first is because when I'm racing, the higher the seconds, the slower I'm going. Therefore, Josh is running much faster because his number is lower. We want to know how much faster he ran. So I'm going to subtract 36.7 minus 32.4, and I get 4.3. 4.3 seconds would be how much faster Josh is running than Jessica. I hope you were able to understand using cubes and figuring out the observations through our word problems. Remember to always use cubes in your word problems and figure out what operation is being used and then solve and check it.